Okay, we are going to prove the following trigonometrical expression: cosine alpha plus cosine 2 alpha plus cosine 6 alpha plus cosine 7 alpha, and that is equal. We need to prove that all this expression is equal to 4 cosine alpha half cosine 5 alpha half cosine 4 alpha. Okay, moving this way. Okay, so what we are going to do here, we have 4 cosine terms, right? Okay, we need to combine 2 with 2, 2 cosine and 2 cosine to apply formula. Cosine, we start early a little bit here. Cosine x plus cosine y, that is equal to cosine x plus y half and cosine x minus y half. And since we have this formula, I'm going to combine, and how I'm going to combine, one would think that right away you would combine cosine alpha and cosine 2 alpha first, right? And then cosine 6 alpha, 7 alpha. I wouldn't do that. Why? Because we are going to, look here, we are going to add, look at the formula, we need to add and subtract and take on half, right? So my goal is going to be to combine them the way, so I will get the same parameters, x plus alpha half and x minus y over 2 parameter. Okay, so for that reason, if I take the cosine alpha, cosine 2 alpha, it's going to be 3 over 2, right? And alpha half. And in this end, 6 alpha, 7 alpha, it will be 7, it will be 6 and a half, 13 over 2, and alpha 2, right? So, therefore, I'm going to choose the combination that will give me same parameters, which means I'm going to take cosine alpha. Oh, might as well I can highlight and it's going to be, I'm going to take cosine alpha with cosine 7 alpha and cosine 2 alpha with cosine 6 alpha. Look at that. Alpha, cosine 7 alpha, it's going to give you 8 alpha, and cosine 2 alpha plus cosine 6 alpha, it's going to get 8 alpha again. So with this combination, it's easier to work usually, right? So let's take care of it. So let's first do cosine alpha, cosine 7 alpha. Okay, it's going to be 2 cosine 4 alpha using this formula, right? 4 alpha cosine 3 alpha. Plus, now let's use cosine 2 alpha, cosine 6 alpha. And now I'm going to use cosine 2 alpha, cosine 6 alpha. It's going to be 2 cosine 4 alpha, cosine 2 alpha. Yes, and that is going to be, so 2 cosine 4 alpha, it's a common factor I'm taking out. And I'm going to have cosine 3 alpha plus cosine 2 alpha. This is equal 2 cosine 4 alpha. Now here cosine 3 alpha plus cosine 2 alpha, I'm going to apply the same formula, cosine x plus cosine y, right? It's going to be 2 cosine 5 alpha over 2 cosine alpha over 2. Okay, so what do we get? It's going to be equal 4 times cosine 4 alpha cosine 5 alpha over 2 and cosine alpha over 2, which we had to prove it. Here it is. We have it here. Okay? Okay, we have 2 sine squared 3 pi minus 2 alpha cosine squared 5 pi plus 2 alpha, and we need to prove that is equal 1/4 minus 1/4 sine of 5 pi over 2 pi over 2 minus 8 alpha. So whatever we need to prove, let me put this way. Okay, this is what we need to get. Okay, a little bit more so we can separate. Okay, so what do we have here? Sine squared, 2 sine squared and cosine squared. Well, I'm going to use a formula of half an angle that says that sine squared alpha half is equal 1 minus cosine alpha over 2, and cosine squared alpha half is equal 1 plus cosine alpha over 2. Let me take it into frame so you will, every time when you scroll, you will see it's a formula here. All right, let's work on it. What we are going to do is I'm going to apply this formula. So 2 stays out. If sine squared 3 pi minus 2 alpha, it's a half of angle, then I'm going to replace with 1 minus cosine. So look here, I have half of alpha and I'm taking here alpha. So it's going to be cosine. Instead of 3 pi, I will end up with 6 pi and minus 4 alpha, right? Double angle, correct? And that's divided by 2. Okay, next, multiply by cosine squared, which is going to be 1 plus cosine 10 pi plus 4 alpha and divided also by 2. Okay, so what do we have? These 2 is cancelled with these 2. We have 1 alpha, 1 2 left, 1 times 2 equal. So from here we are going to see what's gonna get here. So cosine, let me do drafting here. Cosine 6 pi minus 4 alpha. So we know that the period for cosine is 2 pi, right? So one circle is 2 pi. 6 pi is a 3 circles, right? And you're still going to end up with in the same position, correct? So can I say that 6 pi minus 4 alpha, it's going to be negative cosine 4 well, positive cosine for alpha. Yes? Okay. So from here, I'm going to write down 1 minus cosine for alpha, because cosine is a, look, cosine is a even number, so cosine negative for alpha is equal cosine positive for alpha, right? Here this is positive alpha for alpha, let's say, this is negative for alpha. Cosine is absolutely the same. They are sharing same cosine. Yes? Okay, so 1 minus cosine for alpha times 1 plus, same way, 10 pi, it's fitting there 5 times full circle, right? 10 pi divided by 2 pi, it's going to be 5 times. So it's from here, I'm going to get 1 plus cosine for alpha, because 10 pi, it will rotate 5 times and end up in the same position, correct? Okay, so divided by 2. Next, we are going to get, look what we have. A minus b, a plus b, which is equal a squared minus b squared, correct? All right, that's going to get 1/2, taking out these 2, and I will get 1 minus cosine squared for alpha, right? A squared minus b squared. Okay, now let's open cosine square half alpha formula based on using this formula. And we are going to get 1/2. Okay, it's going to be 1 minus, we are getting here 1/2. And on the top, we are getting 1 plus cosine 8 alpha plus cosine 8 alpha. Yes? And the result is 1/2 stays out. And in parentheses, I have 1 minus, so I'm going to divide by 2, separate 1 over 2. And because we have negative in front of fraction, we treat as a negative sign in front of parentheses. So it's going to affect the sign of cosine 8 alpha. It's going to be minus, because we're opening parentheses, kind of, right? Cosine 8 alpha over 2, or 1/2 of cosine 8 alpha. So, and from here, we are getting 1/2. 1 minus 1/2, it's going to be 1/2 minus 1/2 cosine 8 alpha. Okay, let's see how far we are gone. It's going to be here 1 over 4 minus 1 over 4 cosine 8 alpha. And we have to prove we have 1 over 4 minus 1 over 4. So here we have sine 5 pi over 2. Sine 5 pi over 2 minus 8 alpha. Okay, let's see what we can do to get from cosine 8 alpha to sine 5 pi over 2 minus alpha. So here is the thing. The cofunction of cosine is sine. Alpha pi minus alpha. Okay, we know this much. And this is, by the way, it's a formula. You can take it as a formula, it's a rule. It is, it's that way. So, for example, real quick, let me see. Real quick to do drafting. Cosine 30 degrees is equal sine 65 degrees. I believe I have video, or sine 50 degrees is equal cosine 40 degrees, okay? So half a pi minus. Now, cleaning this. So if I have cosine at alpha, it's going to be equal sine half a pi minus 8 alpha, yes? But we need 5 over 2 pi. Well, let's see. 5 over 2 pi. So if this is my half a pi, because I have to take half a pi minus, so it's right here. So 5, how many degrees is 5 over 2 pi? Let's see. 5 over 2 pi is 5 times 180 divided by 2, right? Pi is 180. This is 1, this is 9. So we're getting 450 degrees. What is 450 degrees? It's a one full and at a circle, 360, right? And then how much will be left there? Precisely 90 degrees, correct? So one full circle and then one all the way to here. So 450 degrees, meaning the 5 pi over 2, and pi over 2 will have absolutely same position, yes? Look here. Let me go one more time so we can see. This is my half a pi, right? Oops. This is my half a pi. So, starting from 0, so I need 5 pi over 2, which is 450 degrees. So if I'm going one circle, this is the 360, right? And to get 450, I need another 90 degrees, right? Which is 90 degrees is this one. And I'm getting here. So be it 450 degrees, be it 90 degrees, it's going to be the same position, correct? So what that give us, it allow us to put 1 over 4 sine 5 pi over 2 minus 8 alpha. Why I put 5 pi over 2? Because that's what they want, to prove that it's the same thing. And position of pi over 2, sine pi over 2, and sine 5 pi over 2, it's the same and it's equal 1. Because sine 90 degrees or sine 5 pi over 2 is 1. So therefore, we can replace it with 5 pi over 2 and minus 8 alpha. Did we get what we wanted to prove? 1/4 here. 1/4 minus 1/4 sine pi over 5 pi over 2 minus 8 alpha. Here it is. We got what we needed to prove. And one more. The last one. 1 minus sine 4 alpha plus cotangent 3 pi over 4 minus 2 alpha cosine 4 alpha equals 0. Okay, this is a little bit challenging, but we can do it. So, what do we have? We have cotangent, we have sine, we have cosine. So it is clear we have to break down into, because let's say, why wouldn't I go convert sine, cosine into tangent? Because cotangent is 3 pi over 2 minus 2 alpha. Sine, cosine is 4 alpha. So there is no any, how to say, communication or any relation between these parameters. So it's easier to convert everything into sine and cosine. At this point, what I'm going to do here. One, I know that sine square alpha plus cosine square alpha is equal 1. I'm going to open up the 1 also representing the format of cosine plus sine. But in this case, I'm going to use, instead of alpha, I'm going to use 2 alpha double angles. Why? Because I have here, let's see, sine for alpha, I can represent sine twice 2 alpha, right? Here also I can represent cosine twice 2 alpha. So I'm going to use 2 alpha, and that 2 it's gonna help you down the road. So I'm going to write down 1 represent as a cosine squared 2 alpha plus sine squared 2 alpha. This is this one. Okay? Next, for alpha, I'm going to write down minus sine twice 2 alpha. So preparing for further simplification. Plus, cotangent, I'm going to represent as a cosine and sine. So it's going to be cosine 3 pi over 4 minus 2 alpha. Here I have sine 3 pi over 2 minus 2 alpha. And multiplied by cosine, again, twice 2 alpha. So we need to bring all this nasty expression, we need to bring to 0. Okay? So what we are going to do, look here. I'm going to open sine twice double angle. So cosine this sine 2 alpha. What I'm going twice 2 alpha, so double angle. 2 alpha will be my x. 2 alpha will be my x, yes. And 2 is going to be 2x, so double angle. I'm going to use as a double angle. So I'm going to have here cosine squared 2 alpha. Let me bring a little bit down so we can, because we're going to have fractions there. 2 alpha. Okay. Next, I'm going to rewrite this formula. Sine twice 2 alpha. It's going to be 2 sine 2 alpha, cosine 2 alpha, right? Because that's a formula. Sine 2 alpha equal twice sine alpha, cosine alpha. Okay? Next, and plus this sine 2 alpha, whatever this sine squared 2 alpha, this is this one I'm writing. Why did I write down in this order? Because can you see cosine minus sine squared formula, a minus b squared, perfect square. Next, plus, let me shrink a little bit so I would have space. Okay. Let's write down carefully so not to mess things up, because I am also a master to do silly mistakes. So let's go carefully. So cosine alpha minus beta. Let me write down. I want to move here also, this one also. There we go. So make a space for formula. I'm going to write down cosine alpha minus beta and sine alpha minus beta. So let me move this further so I will have space for formula. Okay, so let's write down sine alpha minus beta, because we have here, we are going to use it. Sine alpha minus beta is equal sine alpha cosine beta and minus cosine alpha and sine beta. And also we need cosine alpha minus beta. It's going to be equal cosine alpha cosine beta plus sine alpha sine beta. Okay, this is the formula we are going to use. So let's use it. First, I'm going to use this one, cosine 3x minus 2 alpha, right? And then sine 3 over pi over 2. Actually, I'm sorry, over 4. See, I told you I'm also a master of silly mistakes. By some reason, 3 pi over 2 became 3 pi over 4 became 3 pi over 2. Okay, so from here, plus cosine 3 pi over 4 minus 2 alpha. It's going to be cosine 3 pi over 4 cosine 2 alpha plus sine 3 pi over 4 sine 2 alpha. In denominator we have sine 3 pi over 4 cosine 2 alpha minus cosine 3 pi over 4 sine 2 alpha. Okay, and all that we still have multiplication by cosine twice times 2 alpha. Okay, so let's do some simplifications because we got the long story as an expression. So what do we get here? Look carefully. Cosine to square 2 alpha minus 2 sine 2 alpha cosine 2 alpha and plus sine square 2 alpha. This is going to be converted into formula, which is going to be cosine 2 alpha minus sine 2 alpha to power 2, right? A minus b squared. And from here, minus, okay, 3 pi, cosine 3 pi over 4, it's negative 45 degrees. Let me explain here. Uh, 3 pi over 4, it's 45 degrees. Why? Because look, 3 times 180 degrees divided by 4, it's 1, and here is 45. So we get 135 degrees. 135 degrees, that's 90 plus 45, right? So this is our 90 and plus 45 right here. So 45 degrees, cosine 45 degrees, it's negative square root 2 over 2. Sine 45 degrees, because we have sine 3 pi over 4, it's going to be positive square root 2 over 2. Because the y here is positive, right? Cosine is negative in this quadrant. Cosine is negative and sine is positive. Okay, so let's work here. It's going to be, I'm going to clean it. We already know that it's a negative square root over 2 and positive square root 2 over 2. Let me go over. So it's going to be plus. We have cosine 3 pi over 2, it's going to be negative square root 2 over 2 cosine 2 alpha plus the sine, it's going to be positive square root 2 over 2 sine 2 alpha. Here is square root 2 over 2 cosine 2 alpha minus cosine 3 pi over 4 is negative square root 2, negative square root 2 over 2, right? Times sine 2 alpha. Now, cosine 4 alpha here, I'm going to apply formula. Cosine 2 alpha is equal cosine squared alpha minus sine squared alpha. Okay? All right. So from here, I'm going to write down times cosine squared 2 alpha. Oops. Saying 2 alpha, typing alpha. 2 alpha minus sine squared 2 alpha. Okay. So it's equal cosine 2 alpha minus sine 2 alpha squared plus taking out negative square root 2 over 2, and I will get cosine 2 alpha plus sine 2 alpha. Okay, and from here I'm getting square root 2 over 2 cosine 2 alpha plus, because I have negative and negative, plus sine 2 alpha. Okay. Actually, this negative I can't take out because it belongs only to cosine 2 alpha. Let me leave it alone. Right here. Okay. And multiplied by, now look what I'm going to do. Here I have a squared minus b squared, right? I'm going to open it a plus b, a minus b, times. It's going to be cosine 2 alpha minus sine 2 alpha times cosine 2 alpha plus sine 2 alpha. Right? This one. Okay? So from here, cosine 2 alpha minus sine 2 alpha squared. So what do we have here? Square root 2 is gone. Since I have negative cosine 2 alpha, I am going to take this negative out in front of fraction. And remember what I told you, every time when you have negative sign in front of fraction, it's going to be treated as a negative sign in front of parentheses. For example, if you have 1 minus 2 minus x, right, over x. If I bring to common denominator here, I'm getting x. Here it's going to be minus 2. See, positive 2 became negative. And negative x become positive x. Okay? So same thing is here. And because I'm taking out negative, so I need to flip the sign for this term in numerator. So it's going to be positive cosine 2x. Or 2 alpha, and minus sine 2 alpha. And multiplying by whatever we have there, cosine 2 alpha minus sine 2 alpha, multiplied by cosine 2 alpha plus sine to alpha, and we divide by cosine to alpha plus sine to alpha. Okay, result is, cancel this with this, and we have, this is the last step, cosine to alpha minus sine to alpha squared, minus, so these two parentheses, if I multiply by each other, I will get cosine to alpha minus sine to alpha squared. I mean this one and this one, right? Whatever survived there didn't cancel. And this is equal big, bold, 0. And that's what we needed to prove. Okay? All right. I'm done. Quite a long solution, but it was fun. It was interesting. I like it. I like challenging one, or as I like to say, nasty problems to solve. Anyway, this problem is for people who like math. Okay. Okie dokie, as I always say, and I'll see you in next video.